Okay, we're going to go over the quadratic formula today. I told you it can be a tricky lesson. So this formula is solving for x. Okay. Now when we're talking about this formula, you see there's many letters. In fact, we have an A, a B, and a C. They all refer to when a quadratic is in standard form. Okay. So in standard form, they help us solve for x, or in other words, the x-intercepts. Okay. We need the formula to be set equal to 0. We need our y to be 0 in order to put it into this formula. Okay, that helps us solve for our x-intercepts. Now, in this formula, we have our b value, negative b, which is taken here, and b shows up twice. So it says negative b plus or minus. And the reason there's a plus and minus, I'm going to explain it, is because we square root a term. We square root b squared minus 4ac. Now, the reason there's a plus and minus at the front is because when we square root something, I'll put an example up here. When we square root something, we technically get two answers. So let's think of the square root of 4. What is the square root of 4? Positive 2 and technically negative 2. Because if I multiply positive 2 times positive 2, I get positive 4. And if I multiply negative 2 times negative 2, I get positive 4. So there are two answers when we square root something. Okay, that's what this is letting us know. And finally, everything, not just the square root, everything above is divided by 2a. So make sure you equate everything on top before you divide by 2a. Many people make the mistake of only dividing the square root by that. Do not do that. Okay? So, this is the major formula we're going to learn today. I put a little side formula here. Kyle, what does it stand for?
Axis of symmetry.
Good. That's the axis of symmetry. So we learned one way when we had the x-intercept. In standard form, we can also take the b value, the negative b value, so opposite of what it is, and divide it by 2a, and that will give us the x value of the axis of symmetry. Okay, that's another little trick here, but I want you to focus on quadratic formula today. So, I have a question down here in standard form. We're going to put it through this formula. The very first step is it needs to be set equal to 0 in order to be finding x-intercepts. Okay, it is equal to negative 5x squared plus 8x minus 3. We need to know what our values are. So our a is negative 5, our b is positive 8, and our c is negative 3. The formula, I'm going to rewrite it again, is x equals. So in other words, we're solving for x. That's what this formula is helping us do. We're finding the values of those x's, specifically when y is equal to 0. It's equal to, and I'm going to color code everything. So negative b plus or minus the square root
Okay, you're gonna give us like an original formula, like in there, you have to pull out.
Yeah, just pulling numbers out. That's it. B squared minus 4 times the a value times the c value, and everything is divided by 2a. So I've color coded it to the colors we usually use for a, b, and c. Okay? So we're going to go ahead and plug these in. We're going to get x is equal to negative. Well, the b values are what? Positive 8. So I'm going to put positive 8 replacing there. Plus or minus. And I know I'm taking a lot of time. But as you get good at this, you can really fill this out much quicker. And we'll do a couple other examples when we get fast at this. Okay. Again, we're going to be using 8, or positive 8, squared, minus 4 times a, which is negative 5, and c, which is negative 3. And all of that will be divided by 2 times our a value, which is negative 5. Okay? So we've replaced all of those variables with numbers from standard form. We're then going to use BEDMAS to solve this. So, x is equal to, what is negative positive 8? What does the 8 become? It's going to become a negative. Okay? I get negative 8 plus or minus. We're going to do a little bit of equating here. What is 8 squared?
64.
64. Good. So we have 64. Now, when we're multiplying, I want you to think of this negative 4, this 4 as a negative 4 when we're multiplying. So let's think of it like negative 4 times negative 5 times negative 3. Okay? So what is negative 4 times negative 5? Positive 20 times negative 3?
Negative 6.
Good. Negative 60. Good for you. Okay? This will be divided by, and what is 2 times negative 5? negative 10. Excellent. We then equate what's underneath the root. So what's 64 minus 60?
4.
So negative 8 plus or minus root 4 divided by negative 10. Now, remember when we factored, we would split equations. Okay? We're going to be doing the same thing here. We're going to split this equation because we're probably looking for two x-intercepts. Okay? Remember, a parabola most likely will cross the x-axis twice because it's symmetrical. So quickly we'll equate root 4. What is root 4? 2, right? And the reason they have this plus or minus is because technically it's plus and minus 2. Those are the two answers. So this is where we're going to split our equation. Okay? In one of the versions, we're going to have x is equal to negative 8 plus 2. Divide negative 10. And in the other version, we're going to get x is equal to negative 8 minus 2. Divide negative 10. Okay? So we split this. We split it because there's going to be two x-intercepts. Negative 8 plus 2?
Negative 6.
Negative 6 divide negative 10. What is that going to be as a fraction? What's a better one? 2 over 5. That's a better one. Or sorry, 3 over 5. Positive 3 over 5 is a better one. Nice and reduced. Negative 8 minus 2? Negative 10 divide negative 10? 1. Okay. So what this is telling us is we've now discovered our two x-intercepts. One at 3/5 and the other at 1. So if we were to draw a rough sketch of this, we have an x-intercept at 0.6. Okay, that's what 3 over 5 is, so 0.6. And another one at 1. So 1 and 0. The other at 0.6 and 0. Now, let's quickly look at this quadratic in standard form. Is it positive or negative, the a value? So which way is it face? Down. So we have some parabola that goes like this and crosses at those 2 points. All right? Now we're going to use that other little formula I gave you. AOS, or the axis of symmetry, is equal to negative b divided by 2a. We're going to plug in our standard form values for that. So our b was positive 8, so we're going to put negative 8, right, because we're plugging in a positive value, divided by 2, and our a value was negative 5. Negative 8 over negative 10 is the same as 4 over 5. Okay, so 4 over 5, or 0.8, is where the axis of symmetry falls. So the line, I wanted that to be a dotted line. The line cutting through the middle here, our axis of symmetry, or the x value of the vertex, is at 5 over 4, or 0.8. Okay? That's the x value of the vertex. We just use the axis of symmetry formula to find that. Finally, how do I find the y value of this vertex?
Oh my god.
Yes, Cal.
Substitute 0.8 into the equation.
Very good. So we take the original equation, y is equal to negative, excuse me, negative 5x squared plus 8x. What was the last one?
Minus 2.
Oh yeah, what a memory.
Oh, yeah.
Minus 3. Okay, we're going to plug in our 0.8. So negative 5, 0.8 squared plus 8 times 0.8 minus 3. Use our calculator here quickly. Don't worry about that number. Negative 5 times bracket 0.8 squared plus bracket 8 times 0.8 in bracket minus 3, okay, is equal to negative 20.2. That's definitely incorrect. Why is this not right? Tell me why that number I found is not right. Negative 20.2.
It's not supposed to be a negative.
Why is it not supposed to be negative?
Because it's already too negative.
Wrong.
Why can the y value of the vertex not be a negative? Because it's facing downwards, which means the vertex must be above the x-axis in order to have two x-intercepts. So who wants to help me out here? I guess I punched that into that calculator.
0.2.
All right.
2,000.
You got should have slipped. All right, after we equate all of this, I must have put a little error there. 0.2. Okay, so we get 0.2 as our y value, which makes sense. That's above the x-axis. So we've gotten the vertex and two x-intercepts using quadratic formula. So if we're unable to factor something, doesn't mean there's not x-intercepts, right? It just means we might need to use the quadratic formula to solve it. And even if you can factor something, the quadratic formula will always work. Right? So if there are x-intercepts, the quadratic formula will always find the intercepts every single time. So even if you want to check your factoring, you can plug the numbers into this equation and you should end up with the same x-intercepts.